Okay, so this is your review sheet for the Chapter 2 test, and some of this contains material going back to Chapter 1, and we're actually going to do these problems together in reverse order. So this is the very last problem on your sheet, and it involves solving a system of equations, actually a system of 3 equations. So I want to make sure that you can do a word problem like this, because you'll see one like this on your test. All right? So let's just kind of read through the paragraph. We know that we have 3 numbers, 3 different numbers that total 6. So right off the bat, anytime I'm asked to write a system of 3 equations, I'm going to have 3 variables. So I'm just going to call x my first number, y will be my second number, and z will be the third number. And the trick to being able to solve these types of word problems successfully is to just pick out sentences, really, that represent equations. For example, this very first sentence, it says the sum of 3 numbers is 6. Well, let's take these 3 numbers, x, y, and z, add them up, and make the total, their sum, equal to 6. Well, there's one equation. Okay, second sentence says the third number is, that's another word for equals, okay? So the third number is the sum of the first and second. All right, so first and second, x plus y. So here is translating that second sentence into an equation. And now let's jump down to the next sentence. The first number is, okay, so x is 1 more than the third number. 1 more is another way of saying addition. So if I take the third number and I add 1 to it, then I've got the last sentence. All right, and so we're ready. We've got the system, and we're ready to solve it. And you can set this up to where you can use either elimination or substitution. It really doesn't matter. I think I'm going to go ahead and just use substitution, because this blue equation says x is z plus 1. So that means I can take z plus 1, and I can replace both of the other x's. Okay, so you see how the bottom equation is set up. It's solved for x. And so here's what it looks like when I actually substitute for x. All right, this top equation, x is going to become, I'll just do it over here, x is going to become z plus 1. And then I write everything else, plus y plus z equals 6. And let's go ahead and simplify, combine like terms. I've got 1y plus 2z, z plus z is 2z. And I'm going to move this constant 1 over to the right side with subtraction, so 6 minus 1 is 5. So let me just pause for a second and make sure everybody understands where we are. Okay, so I've substituted into the top equation. Now I'm going to substitute into the middle. So now, in this middle equation, I'm going to let x become z plus 1. So z equals z plus 1 plus y. I replaced x here, and we already replaced x up here. Well, the z's are going to cancel when I subtract. Z minus z is 0. And when I solve for y, I'm going to get y is negative 1. All right, so I found the first of my 3 numbers. I know that the second number, or the one that I'm calling y, is negative 1. And now I just go back up through my work. Question? Well, when you subtract, when you're solving for y, you have to subtract. It's positive 1 now. Okay, any other questions? Yeah? If you're using elimination, that normally happens, but since we're using substitution, it doesn't always happen that way. Okay, everybody good? All right, so now that we know what y is, we can pretty easily come up here and find x and z. Let's find z since we know what y is. We can come up to this red equation. And let me hold off just a second. Let's just back up through. Let's come up here to this equation. And we'll find z here. Okay, since y is -1, let's plug into this and find z. So I'll give you just a second, and then I'll call on somebody. After you've replaced y with -1, what is z? So let's see, Ethan, what do you have for z? Is 3? Everybody got that? Because when you add 1 to both sides, 2z is 6. Z is 3, so we got 2 of our numbers. And now you have a choice. Since you know now what x, or when you know what y and z are, you can go all the way back to the beginning. You can use this blue equation, plug in what you know for z. You got a couple of different options here. This looks like the easiest route. If we just go to the blue equation and replace z with 3, what does that make? Faith, what's x? 4. Okay, so we now have all of our numbers. Okay, any questions? We're finished. So I just want to make sure you can, the big goal of this problem is, can you take these sentences and can you make equations out of them? And then go from there and solve the system using either substitution or elimination. All right, if there aren't any questions, let's move on to this. Well, this problem, I've already handed you the system. You don't have to come up with it, obviously. You're going to solve it. Yes? Yeah. X is 4, y is -1, and z is 3. All right. Ordered pair. I'd rather you not in word problems. Literally, you could just, and what I've done here is fine. What is the first number, what is the second number, and what is the third? Now, when we do this next problem, yes, we're going to write the answer as an ordered triple. Okay, so once again, you have a choice. You can use either substitution or elimination. I personally would like to use elimination in this problem. And it looks like the easiest of the 3 variables to eliminate will be z. So what I'm going to do is I'm going to make 2 pairs of equations. I'm going to take the first equation and pair it up with the last. So it's going to look like this. Okay, first equation with the last equation. And we'll come back to that in just a second. And then maybe over here, different color. I'm going to do the middle equation with the last equation. Equations 2 and 3. Okay, and now the goal is to eliminate the same variable within each pair. And obviously I've already identified z, so I've got to eliminate z in the blue, and I also have to come over here and eliminate z in the red. Okay, so to eliminate z, I'm going to multiply this bottom equation by, you could either do -5 or +5. I think I'm just going to go ahead and do -5. So I'm multiplying the bottom equation all the way across by -5. All right? And so that makes positive 25x minus 15y, positive 5z, and then 17 times 5. What is that, 85? Well, I'm trying to eliminate z, and I'm trying to create an opposite term to -5z, so I multiplied the bottom equation by -5z. And so we won't get all confused, I'm just going to mark this one out. So everything on the bottom got multiplied by -5. Okay, and let's just go ahead and do the elimination. I'm going to add all the way across. So Tristan, what about the x terms when I add those together? 27x. Olivia, what about the y's? All right, plus or minus? Well, maybe, yeah, mine's going to be negative. You might have set it up differently. The z's cancel. And when I do 18 plus 85, $103. Okay, everybody good? All right, over here we're going to eliminate z also, since we eliminated z in the blue. And so we're going to eliminate z here by multiplying by -2 all the way across. Or +2. We can do +2. You could do either. We'll just do the same thing. We'll just set up opposites. I think that's what most people like to do. All right, so I'm multiplying by 2 all the way across. -10x plus 6y minus 2z is -34. And now I don't want to have to look at this one. Let's just make sure I've multiplied correctly. 2 times everything. And now we can get rid of this. And eliminate using addition. -3 plus -10 is -13x. 6 plus 5 is 11y. Ooh, that looks good. It's going to eliminate real well. And -27 plus -34 is -61. Okay, now what? Reagan, what do I do next? Well, I'll throw it to Bess. Bess, what do I do next? Okay, so give me some specifics. We may have some people that aren't really sure. So I guess what you're saying is take the blue 2 variable and the red, these 2 that remain, and put them together. Okay, sounds good. And we're going to do elimination. Okay, so there's the equation from the left. Here's the equation from the right. And it's set up perfectly for elimination. I don't have to do anything. I can eliminate y automatically with addition. So 27 plus -13 is 14x. And somebody can help me with 103 minus 61. 42. So we're feeling pretty good because we didn't get any fractions. I can go ahead and promise you that I'm going to give you a 3-variable system that should not have any fraction answers. So if you get a fraction answer, you know you've done something wrong. All right, so I know 1/3 of my final solution, x is 3. So Hannah, how can I find my next variable, and what variable will that be? Okay, so which variable will be found next? Well, we've already found x. Yeah, we're going to find y, and you can plug back into either one of these. You can replace either one of these x's with 3. And you can use a calculator on this test, so that shouldn't be too much of a problem. I'll just go with the top since we've got a negative here, so hopefully you got your calculator, you can help out. 27 times 3 minus 11y is 103. 27 times 3 is 81. Subtract 81 from both sides, and that should be 22. And we end up with y is negative 2. 2 down, 1 to go. Okay, Catherine, how am I going to get z? Okay, does it matter which? Okay, I'll let you choose. All right, let's go all the way to the top, and we're going to replace x with 3. We're going to replace y with negative 2. And we're going to find z. So go ahead and work on it, and we'll see if you get the right answer. Okay, so raise your hand if you got z is negative 4. Z is negative 4. Great, you are correct. And hopefully you're able to see how we got that. But if you're not, raise your hand. Now's a good time to ask. Any questions? Yes? Okay, that's a great question. If you only know one of the three, then you're going to have to go to an equation that just has 2 variables in it. All right, that is a good question. So when you found 2 of the 3, then you go all the way back to the original. Yeah. No, that's a good question too. He said, does it really matter how you pair them up? And I'm going to say no, it doesn't matter, but sometimes there's a better way depending on how the problem sets up and depending on what you want to try to eliminate. But no, you can set them up in however, I mean, you're limited obviously, but it doesn't matter. You'll get the same answer if you do the math right. All right, anybody else? Okay, let's move on. This is number 18. I'm going to ask you on the test, and you had one like this on your last test, I'm going to ask you to create a 2-variable system and then solve it. 2 variables means I need 2 equations. I need a variable to represent each of the 2 items being talked about in this problem. So this particular motel or whatever it is, they have 2 packages, and the packages contain so much that it costs to stay a night and so much for meals. Our job is to figure out how much is a night, how much does it cost to stay a night, and how much is a meal. So if you're wondering, how do I set up the variables? Well, the variables should answer the question. So I'm going to let x represent the cost of a night. And y will be the cost of a meal. And now I'm going to read the problem using these variables, and I'm going to pick out 2 equations, sort of like we did with the 3-variable system. The sentences will lead us to equations. Like, for example, here's one. For 2 nights, 2x, and 4 meals, 4y, the cost is $158. 2x plus 4y is 158. Okay, the next sentence leads me to another equation. For 2 nights, 2x, and 6 meals, 6y, that comes to 198. And now you are able, I'm going to let you use either substitution or elimination. I think you're probably going to choose elimination. It sets up really well to eliminate x with subtraction. If I subtract these two equations, I get 0x. 4 minus 6 is negative 2y. And 158 minus 198 is negative 40. So y is 20. So the cost of a single meal, this is packaged into multiple meals, but the cost of just one meal is $20. And then to find the cost of a night, I just take my value for y and plug it into either one of these. So I'm just going to go with the top. 2x plus 4 times 20 is 158. This is 2x plus 80. Subtract 80 from both sides. 2x equals 78, so x is 39. So each night, individual night, would cost 39 bucks. So there's my answer to this. So I'm going to ask you tomorrow to be able to write the system. You get points for coming up with the system correctly, and then you get additional points. It's about half and half. Half for coming up with the system, and then the other half of the points will be solving it correctly. Yep.
So you get numbers like 52x plus 4y and the bottom of 52x plus 6y. You're going to put like the numbers in this problem.
Mm-hmm.
Like why do you need the variables?
Well, this says for 2 nights. So if I want to know how to come up with this $158, if it costs me that, then 2 separate nights times how much do those separate nights cost? And then I'm going to eat 4 meals. Well, how much are they a piece? 4 times what number? And then I let that equal the total night, or the total cost for that particular package. Yeah? If you set your variables up like I've done here, where you say x is cost of a night, and then you just come up there and plug it in beside it, I'm fine with this. But some people don't tell me what the variables represent, so therefore you need to give me some sort of sentence. Okay, that makes sense? Any other questions? All right, let's move on to number 17. I want you to be able to be good at solving an equation that's already solved for one variable, but solve it in terms of another variable. And this is Pemdas in reverse. Okay, so I'm going to go ahead because I think this is a good idea. I don't see any parentheses here. I'm going to put my own. Anytime I've got a fraction and I've got adding or subtracting in the numerator of that fraction, I'm going to surround that numerator with parentheses. And so now when I check off the parts of Pemdas, I'm going to undo addition, I'm going to undo division, and then I'm going to take care of the parentheses last. So we're going to go in reverse order. Okay, so addition is the first thing to undo. I'm adding C. How do I undo adding C? I subtract C. So after subtracting C, I'm left with this. Okay, that's done. Now I'm going to undo division. And the way I undo division is with multiplication. So I'm going to multiply by z on both sides. So you need to be careful at this point. I'm multiplying z by this entire side. So show me that. This indicates that z is being multiplied by everything. Hold on just a second. Can't see that back there. All right, and so my final move is I'm back. Really, I'm going to reassess Pemdas. The only thing I have left is to undo subtraction, and I do that with addition. And so this ends up being my final answer. But again, if you did go ahead, I wouldn't take the time to do it. especially if you're running short on time on the test. You don't have to distribute here, but if you do, it's okay. It won't be wrong. Any questions on 17? All right. 16, graphing absolute value functions. Good? All right. When we graph absolute value functions, the best place to start, since this has to produce a V shape, absolute value should always produce V's, so find the vertex of the V. And you find the vertex of the V using this little formula. And in this particular problem, M is 1. It's the number in front of X. B is 3. It's the other number inside the absolute value. If there isn't another number being added or subtracted, B is 0. And C will always be the number outside of the absolute value walls. If there isn't one showing, just assume that it's 0. So when we put all this together, the opposite of B over M, that's negative 3. The opposite of 3 over 1. And C is negative 2. So that becomes my starting point. Negative 3, negative 2. If you plugged in, the formula already has a minus in it, or a negative. And B is 3 and M is 1. Yeah. It's this one. Yeah. M is in front of X, B is inside the walls, added or subtracted, and C is out here. All right, so this is our starting point. It's got to open up because 3 is positive. I know that. So you got to be careful here because the slope of these actually 2 lines, to make a V, I'm going to have 2 lines coming out. The slope is going to be positive and negative 3. And where did I get 3? I got 3 by multiplying the 3 that's outside of the absolute value times that 1 in front of X. So you do need to be careful here. If there's a number in front of absolute value, use that number to help you find the slope. And so from here, from this red dot, I'm going to do a positive 3 slope and a negative 3 slope. I'm going to do that one more time. Positive 3, up 3 right 1, and up 3 left 1. And that is how I'm going to draw the V. Okay, question? Everybody good? All right, let's do domain and range. The domain for these absolute value functions is always going to be the same. You're always going to have all real numbers being utilized from the x-axis. Do I need to answer something? Everybody good? Yeah. These? I started at the vertex and I counted, you have to calculate the slope by multiplying 3 times 1. So do a positive 3 slope, up 3 right 1, and then do a negative 3 slope, up 3 left 1. Yeah. Do you mean M isn't 1? Yeah, that's a good question. If there was a 2 here, I'll just say what if. Inside the absolute value it said 2x. Well, now I'm going to have a slope of 6, positive and negative, 3 times 2. So pretty skinny V. Catherine? To get the slope. That's true. So it's like multiplying by 1, which doesn't change anything. Yeah. Sydney?
So if there was like a 2, if the n was 2x and there wasn't anything outside of it, what?
Slope is 2, positive and negative. Right. Yep. Yep. You find the vertex. No, this number out front of the absolute value doesn't change the vertex at all. It only affects the slope. If this were 2, then the x-coordinate here would be negative 3 over 2. Yeah. This number outside the absolute value does not influence the vertex at all. It just adjusts the slope. Okay, range. It looks like we're picking up from the y-axis here and going up forever. That number that I marked on the y-axis is negative 2, so the very bottom of this v is negative 2 on the y, and it just continues to go up forever. And so the range is going to be all y such that y is greater than or equal to negative 2. All right, if you don't have any questions, we'll move on to number 15. So this is a piecewise defined function, and in problems like this, we're given the graph, and it's our job to come up with the actual function. So it is a single function, but it's actually going to be represented in 3 different parts. So since the y-axis is called f of x, we'll call our function f of x. And now let's see if we can come up with the 3 different equations that represent the 3 different pieces. So I'll just color code like the pieces are. I'll start with this red horizontal. Well, it's a part of a line. If the line did extend all the way to the right, it would cross the y-axis at 8. And so horizontal lines that cross the y-axis at a particular number are always written as y equals that number wherever they cross. Well, you can think of f of x as the same as y. So the equation for this red line, it starts off as f of x equals 8. But it's not the entire line y equals 8. It's only for certain values of x. So if you need to, just go to the end of this red line. You see the solid circle. And you can trace down to the x-axis. And notice that from that line that I've made on the x-axis, the line continues to go to the left or to the negative. And so we're only going to show the x-coordinates on this red line that are for x's that are less than or equal to negative 1. So I marked negative 1, and according to the line, it continues to go negative. So that takes care of the equation for the red piece, and now let's jump into the blue piece. Okay? So let's analyze the line for just a second. It has a y-intercept of 0, so I'm just going to come down here and do a little work. Our b is 0, and if you start there at the origin and you count the slope, you would go up 2, right 1, up 2, right 1. That's a positive 2 slope. So if we know the slope of a line and we know the y-intercept, y equals mx plus b, that means that y equals 2x. And since b is 0, I don't need to write plus 0. That's not really necessary. So that's the equation for the entire line. But I'm not looking at the entire line. It's just a piece of the line that goes from x is negative 1 all the way over to x is 4. So I'm going to restrict this. It's called a domain restriction for only these x's. It's the line f of x equals 2x, but only if I'm going to show the numbers between negative 1 and positive 4. And notice since these are both open circles, I'm not going to say or equal to. All right. Red piece done, blue piece is done. Now let's work on the green. Okay, so for the green, I'll just erase this previous work. Let's see if we can determine what the slope of this green line is. So, Kyle, what do you think? What would the slope of this be? Well, the slope's a number. Are you meaning negative 1? Okay. I'd agree, because from here you would go down 1, right 1, and down is negative, right's positive. So for the green line, we know the slope is negative 1. We can't see the y-intercept, but it's pretty easy to get to. If we just keep on doing that negative 1 slope, we will eventually land on the y-axis, and we can see that the y-intercept should be -4. So if we know the slope and we know the y-intercept, Micah, can you put that together for us? Y equals, okay, -1x minus 4, but only for certain x's. So once again, you may not need to do this, but I'm going to take this end point and then I'm just going to go straight up to the x-axis and make a mark, and then notice the line continues to go down, and more importantly it continues to go right. So it's only going to be for x's that are from 4 and greater, or using inequalities we would say x is greater than or equal to 4. Not until we get to the range. The range deals with where is it going along the y-axis. Okay? Any questions so far? And we're about to do the domain range, so let's go ahead and take care of the domain. Domain says, all right, if we were to take these three pieces and think about maybe laying them one at a time on the x-axis, how much of the x-axis would be covered? So the red would cover from here left. The blue picks up there and covers from -1 to 4, and then the green picks up there and covers forever right. So it looks like everything on the x-axis is covered. So this is going to be all real numbers. What about the range? Anybody want to take a stab at the range? If you take these three pieces and lay them on the y-axis as they show, are we covering the entire y-axis? It looks like there's a gap here that's not being covered, and obviously there's a bunch of numbers going this way that are not covered. Anybody want to take a stab at the range? I'll get you started. It's going to be the f of x such that, well, I'll get us started. The y-axis is covered by this blue piece from -2 all the way up to +8. That is all covered by that blue piece. And actually, the blue has an open circle, but it's like the red fills in the circle. So +8 would be included, but -2 would not be because the open circle here on the end. So the way I would show all of the numbers in between -2 and +8, be careful that you don't use just regular x here, because I need to know that you understand that range deals with the y's, or you can use f of x denoting the y-axis. So be careful. Also, open circle means not or equal to. We're closing this circle, which means it should be or equal to for the 8. Any questions on that problem? All right, and we got part of the range, so somebody want to take the rest of it? What else of the y-axis is being covered? Think of the green line, or ray. It starts, go ahead, Campbell. Very good, because if you just take the end of this green line, go to the y-axis, it starts there, and according to this, it's going to continue to go down forever. And he's exactly right. This would be f of x, or if you did y, that would be okay. Less than or equal to -8. And we are done with number 15. Any questions? No questions? All right, let's go to number 14. On number 14, we're given the function, and it's our job to come up with the graph. All right, so let's take this red piece. Kate, can you help get me started? How would I first of all graph y equals 2x plus 3? Trent? If I just ignore this, is this confusing you? The if x is less than 1? If I just said, give me the graph of this. Okay, start at 3. And then, okay, up to right 1. I'll go ahead and do down to left 1. All right, and apparently we're not going to show that entire line. We're only going to show the line for x is less than 1. Okay. Okay, so this would be the entire line, but if we're only going to restrict it for x is less than 1, well, here is where x is 1 on the line. It's that red dot right there. I went to the x-axis at 1, and then I just went up until I found the line. And since it doesn't say or equal to 1, I'm going to make that an open circle. And I'm going to draw the line going to the left. Less than 1 means to the left of 1. So with your straight edge, you're going to go this way. All right, 1 piece down, 2 to go. Josh, can you help me out with y equals negative x plus 2? All right. Down 1, right 1. Okay. Or you could do up 1, left 1. Now, I'm only showing this part of the line for x values between 1 and 2. Okay, so here's where x is 1. Here's where x is 2. That's a pretty short little segment. I'm only really showing that little piece right there between x is 1 and x is 2. So these other green dots that I made, just to help me get an idea of what the line looks like, I'll just erase those and make a little segment right there. All right, any questions? Feeling pretty good? Okay, Jackson, help me out with the line y equals 3. What's that look like? Horizontal? Okay, horizontal. It crosses y at 3. But how would I show it if I'm only going to use x coordinates that are greater than 2? So 3, 2, open circle, and which way am I going? To the right. Oh, do this in black. All right, we got our pieces drawn, so let's work on domain and range. BJ, what do you think about the domain? Okay, looks like every single x coordinate from the x-axis will be used if we put all 3 pieces on the x-axis. Landon, what about the range? Let's just mark where it starts. It starts here. This red piece is right there. Nothing above that is being used in this graph. And the red would also include the black, and it would also include the green. Those are all involved. It's like duplicates. So how would we show all of the numbers that fall below 1, 2, 3, 4, 5 on the y-axis? Less than what? 5? Okay. And would we say or equal to or just regular? Okay. All the numbers less than 5 are involved in these three pieces as y-coordinates. Any questions about domain, range, sketching the graph? You feel good? Is it getting easier now that you've done it a few times? Okay, moving on to number 13. Let's graph this quadratic equation, y equals 3x squared. Remember, if it's x squared, you can always remember what the graph should look like. Just think of the u and the word squared. The word quadratic literally means squared. And this is a quadratic function, and it's got to produce a u shape when it's graphed. It's got to. All right, so to see what the u is going to look like exactly, we're just going to do a little table. And we're going to do some inputs and outputs. So I'll get us started. I'm going to input 0 for x. If I do 0 for x, 0 squared is 0, 0 times 3 is 0. So that tells me that the origin is going to be on this graph. It's actually going to be the vertex of the u. All right, so let me do another input, like 1. So Samantha, if I input 1 into this function and then do the math according to order of operations, what's the output? 3. So the point 1, 3 is on this graph. And since we know that this is the vertex, that means there's a symmetry line. Remember we talked about a line of symmetry? Symmetry creates sameness on either side of the line. So that means that there's another matching point on the other side of the y-axis. So I don't have to calculate it. It's just there for me to plot. When you get 1 point on a parabola, it's like getting 2. All right, so let me go with Jake. I'm going to do one more input. Input 2. 212, and that's kind of high up there. I'm not going to change my units, but we're going to do a little estimation. I think, correct me if I'm wrong, that's 10 at the top. Is that right? Can you count them for me? I'm just going to say that's 12. And I can match it up on the other side of the AOS and do my best to make a U shape. It's going to be kind of skinny, but it's not a V because it's not absolute value. So there's the graph, and now let's do domain and range. So let me go to August. What do you think the domain of this graph is? So can you tell, remember our end behavior discussion as x approaches positive infinity, f of x approaches, remember that? So let's talk about it here. As x approaches positive infinity, where's the graph going? Okay, so it's going to continue. Every single x is going to be involved in this graph. It's just going to continue to take on this shape. It's just going to get a little bit wider, a little bit wider. The bigger numbers we choose for x just means it's going to be that much bigger number for y. Okay? What do you think is going to happen going this way? Okay? So domain means if I look at the x-axis, what numbers from the x-axis would be used as coordinates on this graph? Every single one. So this is going to be an all real numbers domain. But that's not true for the range. The range means what numbers from the y-axis are are utilized or used as y coordinates on this graph? Well, nothing down here is. None of these are involved in this graph. None of these can be part of the range. So Josh, where does the range begin? Okay, and going up, how do we say that using an inequality? Y such that? Okay, very good. Starting at 0 and then just getting bigger from there. Okay, any questions?